understand SQL structure. 8.1 database schema. Right. First, let me explain this database schema concept a little bit. Before I explain the details, first, just one sentence description. When we say schema, just a database definition, how do you define your database? Yeah, so that your definition, that part we call schema. Okay, yeah, the short description. That's the database definition. The definition part, okay? A sequence of SQL statements. Or we say the metadata. Yeah, metadata. All right, yeah. Or we say, what do we call metadata part? Not including the primary data. Our business, not including that part. Not including the business data, the primary data part. Yeah. Only the secondary data part. Okay, that's the schema. Okay, yeah. Specified during the database design. When you design your database, you write the SQL statements, provide the details, define your tables, constraints, everything you need, all the constructs you need for your database. All right. Not expected to change frequently. Yeah. So here, not expected to change frequently with respect to data change. So this part I like to explain in this way. With respect to data change, we know we change our business data frequently, right? Yeah. And we do not change our database structure as frequently as our business data for that kind of comparison. But it does not mean, because you may need to do a lot of change in your database design. Yeah, here, yeah. Especially at the early stage of your database design. Because at early stage, you do not have a good idea what should be the best way for your database, right? Early stage, you need to understand your project, right? Yeah, at the beginning, you may not have a good understanding of your project. So your initial database design needs to be changed quite a lot at the beginning. Later, because when you have better and better understanding, your database becomes stable. Okay, so after it is stabilized, then we do not change much and frequently. Yeah. Okay, so that's the typical situation. Okay. All right. Yeah. Schema construct. Yeah. So what do we put? What do we need to define, describe inside our database schema? Yeah. The schema background, I will explain a little more later. Yeah. The schema, the old way, history, and the current schema is different structure. Yeah. First, entity concept, entity construct, entity. So what's that entity? Yeah. It corresponds a row in a table or a record, entity. Yeah. But actually this understanding is is not accurate. Yeah. So you see, visually it corresponds to this, but so I like to say this description not accurate. Accurate. All right. Yeah. Why? Because when we talk about entity, what do we want to describe in our business world? An entity represents a real world object, such as employee. Okay. Real world, it's an object. That's the fundamental meaning of that entity. Or student, just a business object we want to describe. Right? This is the fundamental meaning of the entity. Okay. Although it corresponds to a row in a table, but some non-entity thing can also correspond a row in a table. Right? So that means this is not fundamental. Yeah, this description not fundamental. Okay, this is fundamental. Okay, yeah. But you may wonder, other than entity in our business world, is there any non-entity thing we like to describe in our business world? Yes. Another important construct here, let's say construct. Yeah. So here, this attribute still the construct inside a table attribute, a column in a table or a field here. Attribute, yeah. Column, when we talk about table, visually, column, rows, yeah, or a field. Yeah. They refer to the same thing, yeah. But you may want to ask why we use so many different names to call the same thing, right? Because we describe the same thing from different angles. Yeah. So things like this, entity, attribute, these things, they are formal names in the academia research. We know the SQL, this database query language, SQL query language, it was created in academia, right? Research first. It's a research project. It was created as a research project first. Okay, yeah. So when it became better and better, then make it to the business world. So, right? But it started as an academic project. Okay, yeah. So formal names, those formal names came from that academic project. Okay, yeah. Then in the business world, business people, they like to call some, everyday life name, right? Not the academic formal names. So they do not feel comfortable, calling the academic formal names, yeah, because our everyday life, we describe table, rows, columns, the business world, they like to use those common names. Yeah. So that's the reason, different names are used. Yeah. All right. Attribute represents some property of interest of an entity, such as the employee's name. Yeah. property. Yeah. One entity may have several properties. Yeah. In the business, we need to describe certain number of properties. Yeah. Then relation table. Yeah. So relation, that's the formal name. Yeah. So corresponds to table. Okay. Yeah. All right. So that's the basic constructs. Yeah. All right. But yeah, table types. Let me see. Yeah. All right. Yeah. Now I get to the question I didn't answer in previous slide. Yeah, because based on my order. Yeah. So this slide I like to explain the question I didn't explain in the previous slide. So for the table types, typically we have two types of tables. The first one, entity type. Object model, it is used to model the objects in the business world. Yeah. So describe object in the mini world, example, employee. Yeah. The second, relationship type. That's another important, different, completely different type of table. Relationship type. So what's that? Why we need relationship type? Yeah. A relationship among two or more entities represents an association among the entities. Relationship. So you may ask, what's the relationship type table? Yeah, so here association is mapping. Mapping gives us the relationship information. Yeah. Example, a works on relationship between an employee and a project. Yeah. Here, what's that? You talk about works on employee project. Yeah, here. Yeah. In this class, we use two databases. Together, in our textbook, two databases in this class. Okay, yeah. The first one called the university database. So we have student, course, grades, that kind of thing. Yeah. I will give you the database script later. Yeah. The second one, that's the main database for this course. Yeah. Because later, all our database queries, we will use the second database called a company database. Company database. Yeah. Here, in the example we use here, we talk about this company database. In the company database, we will have 6 tables. With data for those tables. Employee is one of the 6 tables. Project, another table. Yeah. Department, dependent, location, and then works on one of the tables. Among the 6 tables, 5 of them entity type. Yeah, so department, project, dependent. Yeah, you can see. Yeah, location. Yeah, all entity type. Only this one works on. That is the relationship table. So you can get an idea. It's quite different from those 5 entity tables. Yeah. So works on, you can imagine it stored information for the mapping association, like employee and the projects. One employee works on multiple projects. Yeah, think about it. Yeah. So if I, draw mapping things, yeah. Employee, yeah, let me write here, okay, yeah. Projects here, okay, yeah. Employee, because we have a sequence, we have sequence of employees. Projects, okay, we have sequence of projects. Then we need to store the relationship. Okay, yeah. For each employee may work on multiple projects, right? Yeah. Usually one employee can work on multiple projects. Okay, all right. But each project, you may have multiple employees in one particular project, right? Yeah. This kind of relationship, think about that. Okay. Yeah. This kind of mapping association, completely different from our entity type, right? Entity type, we describe typical business objects, properties for each object. Here it's different, mapping relationship, okay? Yeah. And here the relationship, there are many different type of relationship. Typically, you can have one-to-one, one to m, multiple m, all right? Okay, m to 1. Is it possible? M to 1, all right? M to n. Here we have m to n. M to n, okay, yeah. This is example, m to n relationship. Okay. Yeah, because later, when people talk about things like this, now you understand what they are talking about. Okay, yeah. All right, yeah. A relationship between a math problem and category. Yeah. Another example. Yeah. We like to store math problems in a university project. Okay. But each problem, we want to assign it some category. Okay? Algebra, geometry, trigonometry, things like that. So it's possible one problem could be assigned to multiple categories. Yeah, in that one particular problem, you may use the algebra methods, trigonometry techniques. All right, yeah. You may use some multiple category content in this problem. Okay, yeah. So you can assign one particular problem to multiple categories. Similarly, each category you have many problems. So that's still end-to-end relationship. Yeah. Okay. Yeah. All right. Allow end-to-end mapping. Yeah. Because in our business world, we have end-to-end mapping frequently. So the basic idea is, if you have certain things that is important in the business world, you need to have the same description in your SQL language. Yeah. All right. History of schema. History a little bit. Early version of SQL did not include the concept of a relational database schema. Yeah. At the beginning, so because when the project started many years ago, decades ago. Yeah. At that time, researchers, they didn't understand the business world well, or the project did not describe the business world well. Okay, yeah. So when they started, they used the simplest structure. So what's the simplest structure? They put all tables, so they put all tables in their database, or all tables for all projects mixed together. That's the old way. Tables are not separated based on the projects. That's the old way. Okay. Yeah. So you have 10 projects. The tables used for 10 projects, all, putting together, mixed, not separated. Okay. As one collection. Yeah. So that's the old way, right? Not separated. At that time, there was no database schema concept. Okay. Yeah. Early version, SQL. All tables relations were considered part of the same schema because the whole collection was treated as one schema, not separated, the whole thing, everything at that time. Okay. Yeah. Definitely, it was not good, not convenient. When you work on different projects, you need to go to all the tables. You need to find appropriate tables for your particular project. Okay, you may find the wrong table, right? Yeah, it's very easy to use a wrong table. So that's not convenient. You need to keep track of all different tables for different projects. Not convenient. Yeah. So the designers, so they have to make important change. Starting with SQL 2, version 2, yeah, group together tables and other constructs that belong to the same database application. Yeah. Same database application corresponding to one project. So let's think in that way. One project, yeah. One project you may use multiple databases, right? Yeah. But so usually if you don't have a good reason, you just use one database for one project. But you may need to use multiple because some databases are shared by many projects. Yeah. That's possible. Yeah. But you need to group, you need to separate different databases. All right. So then this database schema concept was created and used for each database. All right. Yeah, that's just some background knowledge for schema. Yeah. When you use SQL, this kind of history knowledge not be very important. Yeah. All right. 8.2, database languages. Yeah. Here we still, we look at these languages. Here, multiple languages, right? Yeah. SQL, we know it's a database language. But here, we may have multiple database languages. Okay. We look at that, look at this from that research project point of view. Research project, okay? SQL. We talk about SQL from that research project point of view. Okay, yeah. Still the background information. in your real world applications, this part may not be important. Because when you use SQL statement, you never need to touch this kind of things. Only you need to know it, a little bit history. Okay. The first database language is called data definition language. And we use DDL for this type of database language. Data definition language. Yeah. That is those researchers, they define in their research project. Okay. Yeah. Define schemas. Yeah. Another type, view definition language, VDL. Yeah. After you define, you need to view your data, right? Yeah. How to view your data? So VDL. All right. Yeah. Specify user views. Okay. All right. Data manipulation language, DML. Another one. Okay. You see so many different names. Okay. Data manipulation language. You manipulate data, you need to use some language. Right? Include retrieval, insertion, deletion, modification of data. Right? Yeah. Then, because here, although we have these three different names, yeah. Then later, the researchers put everything together. Yeah. So they create the SQL language containing all of them. Yeah. SQL, a comprehensive integrated language. In SQL, we have everything of the three types above, DDL, VDL, DML. Okay. But we do not need to separate which part is DDL, which part of VDL, which part is DML. That's not important, right? We just use SQL. We just use the SQL to get our job done. That's important. So for that reason, when we use SQL language, we don't care the specifics of those three different types of database languages. Okay, yeah. So that's why I said we, from the research project point of view, yeah. So researchers characterize those three different database languages. For our users, we are users. For us, it's not important. All right. Combination of all these three. Yeah. Okay. Yeah. So here you can see a lot of things of SQL connects to the original research project. Okay. Yeah. Yeah. Because actually in business, many products, they have their original research projects. Okay. For example, Google search engine. You know, the famous Google search engine, right? Yeah. A famous example, here, yeah, let me write it. One famous example for research project, university research projects. Okay, now that is the Google search engine. Okay, yeah, because two Stanford students, their PhD thesis, think about that. Two Stanford, you know, that's the two founders of the Google company. Okay? Stanford, you know, PhD students. Their research project in Stanford, dissertation, okay, that's the, the research project, okay, then commercialized. Think about that. Many successful business projects came from academic research projects, okay. Yeah, statements for constraints, specifications, schema, evolution, etc. All right. All right. 8.3, properties of SQL. We want to understand a little more about SQL. Okay. Yeah. Properties of SQL. The standard language for commercial relational database. SQL, the SQL is industry standard. Right? Because it's a standard. All the business people, if you want to use the relational, here specifically for relational DBMS, you have to use SQL. That's the standard. Everybody should follow that standard. Okay, that's important. Otherwise, how people communicate? Okay, if people use different query languages, it's very hard to communicate. So right now, for relational, I emphasize just special type because right now there are some non-relational DBMS. Then you don't need to follow this standard, right? Yeah. So for relational DBMS, you have to take the standard. Okay, yeah. A comprehensive database language. Yeah. Both DDL, DML, also that VDL, right? Yeah. It has facilities for defining views on the database, specifying security authorization, permission for different users, grant different users the privileges to access different tables. Yeah. So in the standard, it has that capability. Because in business world, that part is important. Different users in a business, they should have different data access privileges, right? Yeah. For business, that's important. Yeah. Yeah. So you can set the privileges in your DBMS using SQL statements easily. Okay. Yeah. Defining integrity constraints. Yeah. We saw some integrity constraints before, right? I gave you 4 different types. Integrity constraints. So you can define integrity constraints using SQL statements. Yeah. Later, we will see some examples how to define different constraints. Okay. Specifying transaction controls. All right, transaction, you know that transaction concept. Okay, yeah. Begin, end, rollback, right? Yeah. Those things. Rules for embedding SQL statements into a general purpose programming language. Yeah. So this part also important. Remember last time I drew diagram, we have many different servers in the world, S1, S2, S3, right? All these servers, they need to do communication, okay? Yeah, all right. And we need to access the database server at different locations. And also, we need to do queries. When we do database accesses, we need to do SQL queries. That means we need to write SQL statements in our general purpose programming language. Okay? Yeah, here. Oh, yeah, that's too low. So yeah, here I can draw. Yeah. All right. In our general purpose programming language. Yeah, here let me use the example. Java, PHP, the general purpose programming language. Yeah. In Java, we need to execute SQL statements. In Java, the technology, one of the technology, because there are many database technologies. Yeah. JDBC. Okay. So that's the Java. That means Java database connectivity. Technology. Okay. Another one I also mentioned before, remember in this class, Hibernate. Okay. Yeah. Yeah. To access databases, you can execute SQL statements in your Java programs. Okay. Yeah. PHP. Yeah. PHP. We do not use any specific technologies. In PHP, we do not have that. Things like JDBC, Hibernate things, we do not have those things. PHP, a set of database DB functions. Use a set of database functions to do the queries. But for different DBMS, you need to use different sets of functions. MySQL, you need to use MySQL database query functions. For Oracle, you need to use Oracle database query functions. They're different. Yeah. But in Java, no. For all different DBMS, you use the same way to do the queries. Same API, okay? Yeah, I will say same API, okay? API, same for all DBMS. But you may wonder, how can you use same API to access all different DBMS with different database drivers? I talk about drivers. To access MySQL, you need to include MySQL database driver as a library file, Java library file, okay? JAR file, Java archive, Java library archive file, JAR, okay? For Oracle, you need to use Oracle library driver file, and so on. Well, in PHP, we do not have drivers file, right? There is no, you don't need to download drivers files. You just call those appropriate functions In Java, same methods, same classes, same methods, same users interfaces you use for all different DBMS, but with different drivers. Okay, PHP, no drivers, but you need to use different set of functions. Okay, so those two different ways. That's in the general purpose programming language. You can embed your SQL statement. Okay? Double quotes. What do you mean embed? Yeah. When you call them, the SQL statement is included within a pair of double quotes. When you use functions, you pass your SQL queries statement as string parameter for that function, for those functions. Okay, Java, you pass SQL query statements as string parameters for certain methods of appropriate Java classes. Okay, so that's what we mean embedded here. What do you mean embedded? That's the meaning of embedded. Okay, yeah, all right. Structure of SQL. Structure of SQL. Okay, yeah. Core part. SQL, remember we talked about industry standard before. Yeah. Here, let me give you further information related to the industry standard. Standard. Okay, yeah, because it is a little more complicated than you can imagine as a standard. Our original understanding, the standard, everybody must follow the standard, but true or false. Part of it is true, but some other part not true. Here, I need to explain the complexity of that part. All right. So first, we look at the core part. SQL, you have SQL core part, core specification. That part belongs to the standard. Okay, core part. Yeah. Supposed to be implemented by all RDBMS vendors. Yeah. Yeah. And those vendors, they follow the core specification well. Yeah. Yeah. That part, no argument. Yeah. Everyone follows the core specification well. Okay, you can implement SQL queries if they belong to the core part, then they can run in all different DBMS, MySQL, Oracle, with the same SQL statement. You don't need to change anything. Okay. But that's only for the core part. Yeah. And there is non-core part, yeah, specialized extensions. Yeah. So here, this extension part, it does not belong to the core part, separated. Yeah. Then for different DBMS, they can define their own extension specifications. So this makes the situation more complicated. Okay, this one you can say that's not part of the industry standard. Okay, yeah. So this part more complicated. Yeah. Okay. Yeah. And for our users, it is much harder because we don't know which part belongs to the core part? Which part belongs to the extension part? We don't know. When you see a SQL statement, is it a core statement or extension statement? Nobody knows that. Okay, no. Only when you have some good search the specification documents, then you can find out. But usually people do not bother to do that kind of search, right? Yeah. Yeah. All right, yeah. So then you only need to deal with them based on your experience. When you encounter the problem, you just try to search the web, different documentation, try to solve that particular problem and build up your experience. Okay, yeah. Yeah. So this part, yeah, implemented as optional modules for different DBMS vendors. They have the freedom to define their extension part. Okay, they do not need to work with other vendors. They just make it for their own product. Okay, yeah. So that part for our users, then it's very hard. Yeah. Think about when you need to convert your database from one DBMS to another one. How much work you need to do? Okay, yeah. Let's imagine we want to convert MySQL query statements to Oracle query statements. Some of them do not belong to the core part. Okay, some of them belong to the extension part. Then it's very hard. It's something like the translation, language translation. In the MySQL environment, you do it in this way, but when you move to the Oracle environment, you have to change to a different way. Here, let me give you a simple example here. Okay, example. Now, based on my experience, okay, simple example. All right. In MySQL, there is a keyword called a limit keyword, limit. Limit, the keyword, usually we use uppercase, okay, limit. Limit, the meaning is obvious, okay? When you retrieve a table from your database, table, we know many rows, right? Many rows. Here, suppose result table, because our query result, okay? Our query result is a table, okay? A table, typically, the structure is like this. There are many rows in this table. Yeah. And sometimes the result table could be very large number of the rows that satisfy your query. Okay. Yeah. Let's imagine 1,000 rows. Suppose our result table has 1,000 rows. Okay. But we do not need to display all 1,000 rows. We only want to display just one segment of it. Okay. certain consecutive rows, small number of, because that part corresponds to page. Think about search engine display your search result, large number of pages, right? But you're only displayed one page each time, right? One page, one segment inside your search result. Yeah, so that usage we encounter frequently in our everyday life. So in MySQL, to get that one page in a large search result table, you use the limit to do that. Okay, limit, you specify the starting point. The segment starts from, which row. Then how many rows in that segment? You specify those two parameters. Then you can get that, right? So that simple usage in MySQL, very convenient. Using the limit keyword, very convenient. Unfortunately, in Oracle, there is no limit keyword. Okay? The way to do the same thing completely different. When you do translation, you need to pay a lot of effort. Okay? You need to write a lot of code. Yeah. So that's just one simple example. Okay. Yeah. Second example, because we use frequently, also in MySQL, there is a feature called auto increment feature. Auto increment feature for the primary keys. Primary keys, sometimes we use the natural numbers 1, 2, 3, every time auto incremented by 1. Yeah, so we call it auto increment. So when we declare this type of special primary keys, we just add auto underscore increment that keyword at the end of the primary key. Okay, then it's very simple. When we create a new row, we do not need to specify what is the primary key. The default one, it automatically adds one more to the previous one. So convenient, right? Auto increment. Okay. But it's not available. This feature is not available in Oracle. Okay. That means when you do translation, you should be very careful. Okay. Yeah. Oh. Sorry. Here, just get recording. Here, these examples just let you know, when we say SQL as industry standard, the situation actually pretty complicated. So in the real world applications, you need to expect to deal with that kind of complexity. Okay. Yeah. All right. Yeah. The consequence in application programs, let's see, when you change a DBMS, you may need to change your SQL statements. But many times, you do not know if you need to change or not. But when you run it, when you have problem, then you realize you need to do the change. Okay, yeah. So that's the typical situation. Yeah. All right. Then our last slide today, SQL terms. Yeah. So here, the relationship, the correspondence. Yeah. I talk about the academic research, language, research model, and then the industry way. Yeah. So here you can see the SQL. Yeah. The second row corresponds to the research project relational model. Yeah. The first line, that's the industry way, so they call. Yeah. So table corresponds to relation. Yeah. Row corresponds to tuple. Yeah. Term. Yeah. So we know the tuple. Yeah. So later we will see, usually we use parentheses. Yeah. A, B, comma, C, tuple. Okay. Yeah. D, all right. Yeah. All right. Column corresponds to attribute. Here, regarding the tuple, because we will use this concept a lot. Yeah. Later, when we do the queries, so we will use the structure of this tuple a lot. Okay. Yeah. So it is an ordered list of elements. Yeah. The main property here, ordered. Okay. Why here I emphasize order? So you cannot switch. So if you list B, A, C, D, then we treat as different tuples. Okay, these two different tuples. Okay, different tuples. All right. Different from a set. Yeah. We have a similar concept, set, right? Yeah. So order. Yeah. So here, the tuple and the set, the concept different. Yeah. In set, the main property, unordered list of elements. In a set, when you change the order of your elements, we do not treat as a different set. Yeah. But for tuple, so when you change the order of the elements, we get a different tuple. Okay. Yeah. So for these two concepts, because in our SQL queries, sometimes we need to deal with sets, our query results. Certain parts, we use the set concept. And a certain part, we use the tuple concept. So order matters. And, yeah. And for the set case, the order doesn't matter. Okay. All right. So these two basic concepts. Yeah. In our later queries, when we write the query statements, sometimes we use tuple, sometimes we use set. Okay. Yeah. Yeah. So you will see the difference. Okay. All right. Let me stop at this point.